Your AI model is lying to you about being smart. Here's the proof. When a mixture of experts model generates a single word, up to 88% of the time it isn't thinking at all. It's just moving weights from CPU memory onto the GPU. A 2026 paper from UMD and Together AI, called Speculating Experts, found a way to predict which weights the model needs next and start shipping them before they're asked for. The result? Up to 14% faster inference, almost for free. And the trick flips one assumption every prior paper made. Modern AI is no longer compute-bound, it's memory-bound. The biggest models, like Qwen 330 billion and GPT-OSS, use a trick called mixture of experts. Instead of one giant brain, they hold over 100 specialist subnetworks, and a tiny router picks a few of them per word. Here's the catch. Those experts don't fit on the GPU. They live in CPU RAM and get shipped across the PCIe bus on demand. On an A6000 running Qwen 3, those shipments eat 84 to 88% of every single token's time. The actual math? 8 to 13%. Your $1,000 GPU is basically a loading screen, so researchers tried to hide the latency. The old approach was to predict the next experts and cache them. But on a wrong guess, you stall, fetch the real expert, and eat the delay anyway. This team made a radical bet: don't cache the predicted experts, execute them. Run the speculated expert with its predicted routing weights and keep going. No refetch, no stall. The insight is that a layer's internal representation, what they call the quasi-hidden state, is shockingly good at predicting the next layer's routing, even in models with 128 experts. Here is the move that separates this paper from 5 years of prior work: speculative execution. Every earlier prefetcher, Prescope, Duoserv, Elisiev, treated a predicted expert as a cache hint. Guess wrong? Refetch the truth, eat the stall, cap your overlap. This paper runs the speculation directly and accepts that the routing is occasionally off, because the model is robust to a slightly mixed expert on most tasks. That single choice is what unlocks real compute and transfer overlap, instead of pretending to. And the accuracy cost? Almost nothing on the right model. On GPT-OSS 120 billion, speculative prefetch scored 0.857 versus a 0.849 baseline. It was literally faster and nominally better. But Qwen 330 billion is the hard case. Naive router speculation cratered average accuracy from 0.817 down to 0.641 because its early layers drift. The rescue is hybrid PF. Run a tiny neural estimator on just the drifting layers, plain prediction everywhere else. Average recovers to 0.766, and on the GSM 8K math benchmark, it lands within a hair of baseline. That tiny estimator is the secret weapon. It's small, between 4 million and 45 million parameters, trained on just a few million tokens by distilling the true router's decisions. On Qwen 330 billion, it reaches 90% average expert recall after only 4 million training tokens. On the GPT-OSS variants, 83 to 88% after 5 million. Beyond the first couple of layers, the plain router already recalls 90% of experts on its own. The estimator only earns its keep where drift is high. Everywhere else, the parameter-free default just works. Picture a busy warehouse. The old dispatcher waited for an order, then sent a forklift to fetch the right specialist, then waited again. Every single order stalled on the fetch. The new system is the dispatcher who watches the pattern and pre-stages the next specialist at the loading dock before the order even arrives. Sometimes they guess wrong, and the wrong worker is sitting there. But mostly the right worker is already in place, and the line never stops. That is exactly what overlapping the next layer transfer with the current layer's math looks like in silicon. Now the payoff. Across hardware and models, speculating experts cut time per output token by 5 to 14%. Up to 14% on Qwen 3 on an A6000, and 5 to 8% on bigger A100 and GH200 GPUs. The theoretical ceiling is 2 times speedup, hit only if compute time and transfer time are perfectly balanced. Real GPUs are lopsided, so you never get the full 2x. But 5 to 14% with no retraining, dropped straight into the open source Yalis inference engine, is a serious free win. So the next time someone tells you mixture of experts models are fast because of sparse activation, tell them the real bottleneck is the bus. Speculate the experts. Execute, don't cache. Keep the estimator tiny and only on the drifting layers. The paper is Speculating Experts, the code is in Yalis, and the lesson generalizes: when your workload is I/O bound, prediction beats waiting. Subscribe for the next paper breakdown.